Okay, so you're all welcome to the introduction to R. And as indicated, this is for absolute beginners. Yeah, so our outline will look like this. We have a preamble, and then we're going to talk about objects. In fact, the whole of the talk is just about creating objects. Then we have some operators in R. That leads us into the data structures that we have in R. Among them, we have the vectors, a matrix, array, list, and data frame. Then we do a recapitulation. And then for those who have time enough, then we have an extra video to show how RStudio is being used or being opened for the first time. So, Pastor Samuel, you're welcome. Samuel, you're welcome.
Thank you, Doc.
Good. So we were just beginning, and I am also recording it on my machine here. But at the end of it, I've posted it on a link, which I'll share with us all.
Okay, thank you.
So let's start with the preamble. When we talk about R, we have three important concepts to distinguish from the other. One of them is R as the software. The second one is RStudio, which is a platform for R. Now they are just changing their brand to call it Posit. And the idea of Posit is that they are going to combine the functionalities of R and Python together, because they have seen that some scientists are working on R and some are working on Python. So now they want to combine the two. So if you have RStudio, it means you can also run Python and you can run R on your IDE. Then the third part of it, the third dimension of R is the point and click interface. So this one looks like Excel or SPSS, for instance. So these are the three important things we have to distinguish. Now, to make it clearer, I bring this. Yes, so this is R. If you want to work with R, the first thing to download is R itself. And this is the link you can download it from. There are a lot of mirrors here. The various universities have hosted R. My former university, VUACAT, it's the main host of R, actually, the rest of the world. But every other university has it. I hope that one day Ghana, we would also have one university hosting R. So when you are downloading, it makes it easier for those in the region. So you need R, is the first thing you need. Now, after getting R, then you come to RStudio. RStudio is a platform that you can work in R from. So the difference between R in its pure form and RStudio is that when you're working in RStudio, as soon as you start typing the command, RStudio will give you suggestions to complete it for you. When you make an error, RStudio would underline it with red. You know that, this code has not been properly written. So to make RStudio work properly for you, you need R. After downloading R for any of these mirrors, then you download RStudio. Also from here, the link has been given here. Now, as I said earlier, for those who came, RStudio is rebranding itself to Posit. So although we are seeing RStudio, very soon we'll start seeing Posit. And there are two versions of RStudio. The desktop one, which is free for us all, and the server one, which is for the developers. So this one you pay, you have to pay for it to acquire it. And this is more powerful than this. But for us, the small data sets we have, we just require RStudio desktop and not the server. Now, the third dimension, as I said, we have R, pure R, and then a platform where you can run R, RStudio. And now this platform, you can also run Python, as I said. And then in any of them, either R or RStudio, you can load these packages. As we go along, you see how to load them. If you load any of them, and the one I'm conversant with is R Commander. In 2002, when I started studying using R, this is what we had, R Commander. As soon as you type this in and you load it into R, it gives you the Excel-like view. So you can do things the way you would have done in Excel or SPSS. So you don't have to start coding and all that. So this one, for lazy way of programming, you don't do much. You just sit down there, load it, and it gives you, you are just using it with ease. Now, a good introduction, you really need a book like this, an introduction to R, written by some of the people who actually have started writing about R for ages. Venables, for instance, I mean, he has some of the best books on R, which is sometimes the Bible of R, Venables, the old R network or R system. Now, let it be clear also that R was based on a programming language that is called S. So at the beginning, when R started, it had a commercial version, which is called S+. They're still being used. That one, as I said, commercial, so you pay for. But R is the perfect demonstration of all the things that S can do, the S programming language. Okay, so in R, everything is an object. Everything is an object. So as soon as you start using R, then you are going to create objects. Now let us delve into that. So what is an object? Maybe loosely we can say an object is a noun. Okay, a table is an object. And some in other languages, what we call variables is what we call object in R. So let's say in mathematics, you say x is equal to 2. So, or x and y, these are variables. Then you are going to assign values to x, then it becomes an object. So an object in R, all that you are working with is just object and object and object, nothing else. So eventually we would see that R belongs to the programming languages that use object-oriented programming. But R goes more than that. And so some of the instances of the objects that we have in R will be a vector, a matrix, a data frame, a list, an array, a factor. Now, as we go along, we'll see what all these means. So the whole of the lecture for today is just about the objects in R. So examples of the objects, as I mentioned earlier, numeric variable is an object, 2 is an object, a vector, a matrix, a list, a data frame, and a function. Very good. So this is the superiority, where the superiority of R counts, that the things, the little things, the small things, the variables you have are objects, but the method you use to analyze or compute some commands which are called functions are also objects. So the little ones are objects and the bigger ones are also objects. So that's why R is a functional language and as well as an object-oriented programming language. So the functions and objects are treated in the same way. It's not like this in all the other languages, Java or even Python. Now, these objects must be arranged in a very orderly manner. So you store them, you store the objects in R, and then anytime you need it, you call it. So the way of arranging and storing them is what referred to the data structure. So what is the structure of the data? Is it a sentence or a word? Is it a numerical value? Or what kind of, what type is it? That's why we have the data structure. So the kinds of variables, I mean, the kinds of classes or descriptions that you can give to the objects you create all constitute the data structures. Yeah, so I've given this this link, which I consulted a great deal. Yeah, so as said already, we have the vectors, the matrix, arrays, lists, factor, data frame. These are the objects we have. Now, let us move on how to start creating them. Yes, so before you be able to create an object, for instance, in R, you need an operation between them. So for example, the variable X, if I want to assign a value to it, I want to say let X be 2 or X be 3. So to be able to assign the value to X, I must put an operator between X and 3. So when I say X is equal to 3, it means anytime I see X, it is holding, it's a placeholder for the object 3. So we have some operators also in R. Some of them are arithmetic operators, relational, logical, assignment. We'll see what all these mean. So let's talk about the first one. We have an arithmetic operator in R. Now, the basic mathematical operations, we use plus, minus, and multiplication. So the star in R is for multiplication, and the division is as usual here. Okay. Now, other operators which R uses are, if you want to get the remainder, 5 divided by 3. So it's 1, remainder 2. So if I want to get the remainder, I say 5 and the percent sign, double of it, that gives me the remainder. Now, if I want to get the division of the first term with the second term, as we go along, we'll see how this is done. Use this division sign. And this is particularly useful for matrices. Now, I want to raise a certain number to the power something, 2 to the power 3. So use this symbol as to raise it to the power. We also have logical operators. So and the logical operator for and in R is the and symbol. Then yes, then the or is this symbol. The not is the exclamation sign. Okay. So we have as we move along, we'll be using more complex operators, logical AND operator and logical OR operator. These are used when there are conditions that need to be checked and executed. Good. Now, yes, we come to the assignment operators. What are the assignment operators? I want to assign, let's say, I have a variable X, and I want to assign it a value 3. Okay. In regular mathematics, we say X is equal to 3. So the equal to is an assignment operator. Now, R has various forms of the assignment operators. Either this one, that's the less than and the dash, combined is one assignment operator. And then equal to is also an assignment operator. And double less than and the dash is also an assignment operator. So would see that this and this can be interchanged, but it is advised that as much as possible, avoid using the minimize the use of the equal to, because you need use the equal. It's better to use the equal to inside functions rather than when you are assigning an object to another variable in the console. Good. Now it will not be clear what this one does, but when we are doing, when we are learning to write functions in R, would notice, would find its use. It is used within a function to call an object which has been created outside the function. This one, the double. Yeah, so the same way we have the right assignment operators. So you can use the left operator as well as the right operator. Good. We have, yes, before I move on, this hash symbol is also good, is also useful. It is not strictly an assignment operator in R, but as soon as you put the hash, it tells R that whatever comes after the hash is a comment. So do not execute it. It's not an object I'm going to call. Of course, when you are going to do Kato or R Markdown, this symbol is going to mean something else. But for now, it's enough to know that this is to make comments. Then miscellaneous operators. The colon is to create a sequence of numbers or vector. Suppose I want to create numbers from 1 to 100. So I'll just say 1:100. So that's it. And as you move on writing functions, I have a set of a vector on the left-hand side and another vector on the right-hand side. So I'm going to ask R, look for the things in the right-hand side and see whether they are in the left-hand side. So that's why we have this symbol. And this is for the matrix, for matrices. We're using it for matrices. Now, as I said, the S language. The S language is the basis of all R. So many of them, you can find it in this book. Well, there are other operators that do not fall under any of the four we have mentioned. So these are usually used when you're writing functions to the double equal to show logical equality. And this is not equal. So greater than, less than, greater or less. Of course, in R, we don't write it this way, you know, less or equal to this way. You put the equal to sign here, and this equal to sign here. Now, the assignment operator, as I said, is the one that helps us to give the objects, the elements that are created, that are to be in an object. So for example, we want to create an object A, and A is going to hold pink pineapple. Okay, so as we see how the assignment operator is used. A. So when I type this into R and I enter, and then I just type A, enter, it will give me straight away pink pineapple, because that's the object I've created. And as I said, you can also use the equal to sign, but the recommendation is that always use this when making object assignments. So you can also assign multiple variables at the same time. We want to give x and x 3 and y is also 3. So instead of writing x is equal to 3, and then again coming to y is equal to 3, we just say A is assigned to B, is assigned to hello. So when I type A, I'll get hello. When I type B, I get hello. So the objects also have attributes. They have length. So for instance, there's an object called A here. And A has elements 1, 2, 3, and 4. As soon as I type A, I'll get 1, 2, 3, and 4. Now, what are the attributes of A? That's a length. What are the attributes of B? That's also length. The same way, other attributes could be maximum, max A, or minimum A. And this is, I mean, the max and minimum for the arithmetic operations. Okay. Now, null objects, which is really just represents nothing. You can just use null to represent it, N-U-L-L, and it means nothing. So when you print A, nothing shows because it's null. Yes, you can also remove objects. An object I created, A is an object. I want to remove it. So RMA, and when you type A again, it says it tells you error. Object A not found, which means that A has been removed. That's how you can remove objects from your console, especially if it is slowing down your work. So this leads us to the data structures proper. I mean, the data structures we talk about, the vector, the matrix, array, list, factor, data frames. Now we're going to create them. Okay. Now, vector is the most basic data structure in R. So we always say R is a vectorized language because vector is the commonest data structure. So of the vectors, we have atomic vectors and we have lists. So list is a data frame by data structure by itself, but it's also a part, an item in and the vector. So it's a type of vector list. And as we mentioned earlier, they have the attributes, and the length function is there, the attributes, arbitrary data, the metadata. So here they'll be referring to what class is it? Is it a string? Is it a word or character or numerical value, or what is it? So there are 4 common types of the atomic vectors: numeric, integer, character, logical, and complex. Oh, there are 4. Okay, so I just added the complex, so 5. Okay, correct that. Yes, we have seen how vectors can be created. We started part of it already in the previous slides. X. Want to create a vector X? You have created X in various forms. X to be any names or whatever, but we can. Yeah, so we can create X here as numerical values 1, 2, 3, and 4. And then Y, we are going to create Y as A, B, C, and D. So once you type Y, once you type Y, you get A, B, C, and D, or Z as 5. So these are all objects you have created: the object X, the object Y, object Z. Now object M, let's create another object M, and we see the colon sign at play here, 1 to 5. So M is numbers 1, 2, 3, 4, 5. So here X is C concatenate. So we are creating an object, C concatenate 1, 2, 3, and 4. We could have just said X 1 is to 4, and it will give us the same thing. Okay, now let us create some alphabets. So we say letters. Just tell X, R, give me the letters, the first 5 letters, and it will give you A, B, C, D in caps. And if I use small letters, if I use small caps, letters 1 to 5 to give me A, B, C, D, small letters. Now I want to create another object. Call it a D or D, Akwesi, Zelensky, Nam1, Agrada, Dr. UN. So this is an object. So as soon as I call Z, it will give me Akwesi, Zelensky, Nam1, Agrada, and Dr. UN. Good. So all this we have created, what we created here is a combination of various classes. Some of them are words or characters. Some of them are numerical values. Now let's find the distinction with them now. So the first one is the numeric data type. These are that can take numbers 1, 34.5, negative 45, and all that. In some languages, this is important to note because in some programming languages, if you don't specify that this is a floating number, it will give you an error. R doesn't. R1 is a numerical, you just write 1, and R changes it immediately to double. That means 1.00. Okay? You don't need to indicate the class. Java, for instance, you have to show the class that it is double before you get it correctly. R does not. And so after creating the object num and call it 1, you want to find what class is it, what type of data is it. It will give you, R will give you the result. Now the integers are can also be created like this. Now integers are, it's important to add the integer, especially if you don't want the 0.0 to come, 16.0. For example, you want to create the years, you want to create the data of the years, inflation, GDP years, years to tell the GDP rate, GDP percent of that. So if you have 1990, 1991, 1992, and if you don't create it as an integer, R will immediately make it 1991.1 or 0.0 and something, which you may not need. So you can create the as integer. So as soon as you say as integer, that creates integer for you. So the number we created here, this number, now I want to create it as an integer. It's also given here. Okay. Now another common way of creating the integer is to use the capital letter L to denote that that value is an integer data type. So if I say int 3, 5, L, so when I print, it will tell me it will print 5 without the L, because R knows that L means you are creating an integer. So we have the complex data types, the numbers that have I, that have real and imaginary numerical value. So I, the imaginary numerical value, you can create them. The R understands it like this. Once you have the I here, R understands it as a complex number. So we have logical data types also. These ones are denoted by true or false. We call it the Boolean values, true or false. So if I create an object, logic, false, R understands, even though I just write the word false, R understands that this is a logical data type. So it prints it immediately, exactly like that. But if I put braces or inverted commas around it, then it is no more a logical data type. We'll see that later. It becomes character. Then that brings us to character. So I want to create an object in R, which are characters. So I'll say character 1, Ghana R users. So if I print character 1, to give me Ghana R users, it knows that it's a class, it's a character. The same way, if you want to create an object, let's say I am an absolute beginner in R. All that I need to do is to say character 1 or Kofi Mensah, and then you assign the value, you say into bracket, I am an absolute beginner in R. When you print Kofi Mensah, it will indicate to you, I'm an absolute beginner in R. Yeah, so you can also use as character to create character words or character objects. Yes, here we did not use as character, but we use the inverted commas, and that tells R it is a character. The same way you can use this. Good. And here we created compound. This is a complex number. Comp 22 minus 6i. It's a complex number. Now, how to create it as a character? Look at what is going to happen. You just say as character comp, and then it turns out to become a character number. Here you don't need to put the inverted commas here. Why? Because comp is already an object in R. False is already an object in R. The things you don't put around, they are already objects in R. Okay, so that brings us to the matrix form of data type or data structure, the matrix. Matrices are created just with the method or the function matrix. So mat1 matrix, I'm creating a matrix of 1, the numbers 1 to 4, and the number, there should be 2 rows, 2 columns. When I type out matrix, I'll get the matrix. The same way for the second one. Now I want to access the matrix, the elements in the matrix. So mat1, this is the mth row, first row, column 2, second row, column 1. Okay. Yes, so now having created these matrices, I can also add them. Matrix 1 plus matrix 2. I can subtract them, matrix 1 minus matrix 2. Of course, we know that the dimensions must be the same for us to be able to do this. And you can also multiply the matrix by a constant, 4 times the matrix 1. Or divide 2 matrices. Or transpose a matrix using T. Not only matrix, T, you can use it to transpose anything, your data set. You want to find the identity matrix, so the diagonals of 4. And the diagonal, find the n identity matrix in the diagonal 4. Diagonal will give you the identity matrix. So diagonals only 1, 1, 1, 0, 0, 0, 0, 0. The rest will be 0, 0 up to 4. An array would see that array is if you take your mind back to, if you have a list of items, you can have a list of items, and list 1 would be numbers, list 2 would be names, list 3 would be numbers, names, complex numbers, characters. So we have different data structures in it. Arrays are also of the same kind, but they are stored in the form of matrices. So list 1 as a matrix, just as we have matrix, if you construct this, create this matrix, it will be 2 by 2 matrix. So the array is going to be a matrix, but the first matrix could be numbers, the second matrix could be something else, and that or that. So multi-dimensional data structures. Okay. So that's why there is also the decision between vector, array, and matrix not to, it's a bit blurred, but as we see, arrays are multi-dimensional. There are more dimensions than matrix. Matrix is one on one dimension, and then 2 matrices. So 2 matrices can combine to become an array. So let us create 2 vectors of different lengths. The first vector, vector 1, has 1, 2, 3 elements. Vector 2 has 1, 2, 3, 4, 5, 6 elements. Now, even though they have different lengths, we can combine them. If you have a data frame, you can't easily combine your data frame like that. So the best way to combine objects with different lengths would be to use an array. So if you have a data set from, you conduct an experiment in one area and you got 10 persons or 10 values, and another area you got 20, you want to combine them. In a data frame, you have to create an additional values for the first one so that the lengths match. But an array can help you to create the two of them, even though they are not of the same length. So this is the usefulness of array. Okay. Okay, so yes, naming columns and rows. We can give names to the rows, and columns, and matrices in the array by using the dimension names parameter. Now let's repeat the experiment we did. This one, we create two vectors of different names, vector 1, vector this. Now we want the column names to be this: column 1, column 2, column 3. The row names: row 1, row 2, row 3. Now, if we combine the two matrices, the names of the matrices should be matrix 1, matrix 2. Let's move on and see what happens, how we are going to combine this with their names. So we are taking these vectors as input for the array, vector 1 and vector 2. That's the input for the array. We saw earlier on that for the array, you can have different vectors of different lengths. Okay, so we are combining these two vectors in the dimension as shown 3, 3, 2. And so each one of them should have at least a set of names. So we're going to use the column names, row names, which we have created. So these are objects we have created. Column names. We have not used anything from R. The only thing we use from R is the C to say concatenated. So it's creating this C. So an array, we have the dimension names, and we said we can give names to the rows, columns, and matrices in the array by using the dimension names parameter. So this is a dimension names is a parameter already, which R has defined. We have not created it. The only thing we created are vector 1, vector 2, and we have the dimension that's been created by R for us. So all that we needed is to say, okay, the dimensions are 3, 3, 2. 3 columns, 3 row, 3 column, matrix 2. Matrix name 2 is here. Okay. Oh, sorry. Yes, so we have created an array. That's an object. Now we are giving it a name. You can put any name there, my array, something. So having created this object, we can output it by just typing the object and enter. So we can also access the array elements. This is a repeat of, yes. We can access the array elements. We say 3, okay, we have the array is 3, 3, 2, right? Now we want just these two without this. Now we want first, third, and first. So print the element in the first row and the third column of the first matrix. Print only the second matrix from here. This is what we created, the output here. Now we are extracting various elements from the array. Okay. Yeah. So these are various versions of the same thing that we have seen already. Okay. In R also has some syntaxes that you can always use, like apply. And it's just like C. If you use apply, this is how it should be. So your vector, then the margin, the second margin, the first margin, the third margin, then the function that you want to use. That's what we have this apply. Very useful, very essential when we are going to work with data. Using the apply function for calculations in an array. So X and array is the margin. The margin is the name of the data set used, and then the function to be applied, whether mean, mode, median is a function. For example, we use apply below in different ways to calculate the sum of the elements in the rows of an array. Okay. Vector 1, vector 2, this is what we created already. As you can see, this hash is just, as I said, it's just to indicate the comment. It's nothing, and nothing relevant actually to the calculation, the creation. It's just to say, oh, this is author's comment. Okay. Okay, so our new array is our new array object we are creating is an array of vector 1, vector 2, dimensions 3, 3, 2. And if I type out array new, this is what I'll get. Now I'm creating, I want to apply. So my array new in the margin 1, I want to find the sum. So they calculate the sum of the elements in the rows of an array across all the matrices. So the sum. Yeah, so lists and arrays, you don't find it's just a thin line between them. But let's look at what happens with lists also. I have a list of I have 3 vectors, 4 objects here. I have a vector, I have a character vector. We've already seen character vectors. I have a logical vector, true, false, and I have a, yes. So I want to create a list of this. This one, vector 1 has 3 elements. This has 4. This has 4. Yet I can create a list out of it. Okay. Now, what I fail to do is, okay, yes, it's there, it will come. How to get the list, the element. Yes. So a list, we are creating another object, list, we call it list data containing string. So string is the word used for character in R. So any character object is called a string. Numbers and vectors and logical values. Good. So we have the string, red and white are strings. We have numbers, we have logical, and we have another one which is also a numerical vector but has has a floating point. It's a floating point. If you print this data, you see that R is going to separate each of them into various dimensions for you because they are of different kinds. Yes, then we can create another one. The list of months here, the matrix, it's a matrix, and then another list here. So list, you can create vector, the character vector, you can create a matrix, you can create the list itself in a list. Good. Elsewhere, I've shown the difference between, yes, sorry. sorry. Okay. Okay. Yeah, so a list can hold items of different types, and the list size can be increased. Okay. An array is a vector with one or more dimensions. So an array with one dimension is the same as a vector. An array with two dimensions is a matrix. And an array with three dimensions, an n-dimensional array. Okay, let's go back. Good. Now, we can also give names to the elements by using a function which is already in R, call it names. So this list which I've created here, I want to give it names to the various dimensions. So I'll call it names data list, and I'm going to assign this name. So the first dimension of the list, you see that it is months, okay? So that's months. The second dimension is a matrix, and the third dimension, miscellaneous. So if I print my data list now, this data list, I'll get 3-dimensional list with headings, with names, month, monad, matrix, miscellaneous. I can access the list elements by just showing some called braces. Okay, the brackets 1 in 1, or if I want the second one, 2, third one, 3. In R, we could just say data list 1 into print, or if you like, you can say print data list 1. Is that the same thing? Okay, so you can also, here I can use the braces here to access the element. You could as well use the $sign to access the element. So data list at data list dollar matrix to give you the element. So either you use the braces or the dollar. Okay. Yes. So now one of the most powerful functions in R is the C. The C does a lot of things. This C here. See, now I want to merge the list, and you can just use C, number list and day list, and it's going to join the two. It's going to merge the two. That's the power of R. C, very important. I mean, just stand for concatenate. Yes, the last one and the most important one for most of us is the data frame. Much of our data is in table or in a tabular form. So for us, we work more with, most of us work with data frames than anything else. So a data frame for storing data tables, it's a list of vectors of equal length. So the equal number of rows, technically, okay? So a data frame, okay. The columns of my data frame would be number list, numerical list 3, 4, and 5. Character list A, B, and C. Logical list 2, 3, true, false, and true. You see that the length of each one of them is 3, 3, 3, 3. So if I create a data frame from this, I'll get number list, character list, logic list. So it will give me a tabular data of number list, character list, logic list. And now if I call this, it will show that, oh, this is a data frame. Then I can now work with it. Okay, So some of the characteristics of a data frame, the column name should be non-empty. So each of the columns has a name. If you don't give it a name, R will give it a name for you, or give it a letter, a number. The row names should be unique. You can remove the row names with null if you don't need them. So the data stored in a data frame can be of numeric, factor, or character type, can be of any type. But each column must contain the same number of items in the same set of items, the same class of items. So when you import data into R from Excel, you are always having it stored to you by default as data frame. So the last one is the factors. I mean, this factors, for example, you have your data, you have gender or sex, male, female, or you want population data, so you want to arrange it 0 to 5, 0 to 4, 5 to 9, in that order. You can make it factors. Or patients, okay, these are positive, negative, these are factors. So the function factor transforms them into factors for you, and it gives them the level that each one of them is. It gives them their levels. So for example, here we have spring, autumn, winter, summer, spring, autumn. So we have spring, one class, autumn, one class, winter, summer. So the number of levels will give me 3, and the factors, if I say factor, S is not factor, now X has been created as factor. So spring is considered one factor, autumn one factor, winter in that order. So to end our little discussion, we say R has various data structures. Is the first thing to know about R as we move on, because other languages have their own structures too. And for most of us, data frame is the one we're going to use the most. Good. So thank you for the attention. And this presentation, I'll just put it on here. And as soon as we finish, I'll load it also on the WhatsApp page. So thank you for the attention. If there are some questions, I take them now. Otherwise, for those who are interested, you can stay on and continue this last part, which is about 10 minutes. Okay. So are there some questions? Okay, so the most important thing is that you download, if you're going to download R, you're going to work with R, you first download this from R project. And then you can work only in R, but that means you should be a profi. So when you are writing, R will not make suggestions for you what you got wrong. Okay. And if you want an easier way of working with R, then you use the IDE, which is RStudio. You download RStudio. That's the link also. You download RStudio, and now you load the packages. I mean, that will be in the next session. But for now, what we need is that we have objects in R, and we have the object data types in R, and we have operators. Especially for us, is the assignment operator. I want to create an object. I have to assign this object to it. I have to assign it by using this symbol. Okay. So I just got this video, which gives an introduction to, it gives an introduction to RStudio.
RStudio is a really popular and versatile integrated development environment, or IDE for short, which you can freely download and install on your computer. RStudio brings all the functionality of R together with your scripts, your graphical output, your file management, and a whole host of...
Please, is the volume okay for you?
...one software package. It also nicely integrates more advanced functionality.
Yes, bye-bye.
Okay.
For creating reproducible reports and version control with Git and GitHub. When you first start RStudio, you'll see something similar to this. In this case, we have 3 windows, each with its own set of uses. You can resize these windows by clicking and dragging on the window margins. You can also minimize a window by clicking on the minimize icon, each of the windows, and reset the window by clicking on the same icon. The large window on the left-hand side of your screen is called the R console. If you were just using R rather than RStudio, this is all you would see. The console is like the brain and is the main way we will interact with R. Within the console, you can see a greater than symbol. This is called the command line prompt, and it's waiting for you to enter some code. We can interact with the console directly. For instance, we can use it like a fancy calculator by entering 2, for example. Once you hit enter, R will return the result, and of no surprise, this is 4. So while writing code directly into the console is okay if you're doing something really quick, but it's a much better idea to write your code into a script and then transfer this code into the console so we can run it. To create a new script, we can either click on File in the main menu, then choose New File, and then select the RScript option. Alternatively, you can click on the shortcut button here and then select RScript. Either way, it does the same thing. And as you can see, a new window appears. This window is called the source editor. This is where we write our code. For example, let's retype the command 2 + 2 again. Notice nothing happens right away, even if you hit enter, which just takes you to the new line in the script. To run our R code, we need to place the cursor on the line we want to run, and then click on the Run button. Notice that the code has been transferred or sourced into the console and it has been interpreted. Alternatively, you can use the keyboard shortcut Ctrl+Enter on a Windows computer or Command+Enter if you're working on a Mac. If you notice on the Script tab up here, we have Untitled 1. This means that the script is currently unsaved. You can save your script by either clicking on the File menu and then selecting Save, or you can click on the Save button, or use the keyboard shortcuts Ctrl+S for Windows or Command+S for a Mac. It's probably a really good idea to save your script regularly. Once we've saved our script, you can notice that in the bottom right-hand pane in RStudio, underneath the Files tab, we can see the file where our new script has been saved. You can also use this pane to navigate through the file system on your computer, where you can delete files, rename files, move and copy files. So staying in the bottom right-hand pane for a moment, we can see that there's a tab here called Plots. This is where any plot we create in RStudio will be displayed. For example, let's create a plot using the plot function, and I want to create a plot with the numbers 1 to 10 on the x-axis and 10 to 1 on the y-axis. Don't worry about the details of this at the moment. We'll go through this in much more detail later on in the course. This is really just to demonstrate producing a plot. Again, we source our code into the console by using the keyboard shortcut, and we'll use Ctrl+Enter on Windows or Command+Enter on a Mac. And our plot appears in the plot window in the bottom right-hand corner. We can make the plot larger by clicking on the zoom button, and we can scroll backwards and forwards through our plot history by clicking on one of the 2 arrow buttons. We can even export the plot to an external file by clicking on the export button and selecting the file format that we require. There are also loads of other ways to export plots from RStudio, and we'll cover some of these ways later on in the course. Another tab we can see in this window is the Packages tab. This displays a list of all the packages that are available to you in your current version of RStudio. We will cover packages in a later video in more detail, but for the moment you can think of them as collections of useful functions, help files and data. Many packages come pre-installed with R, or you can download and install additional packages to increase the functionality of R. You can also install these additional packages by clicking on the install button, or update your packages by clicking on the update button. Again, there are other ways to do this, which we'll cover in a separate video. Another really useful tab is the Help tab. The Help tab displays the help file on any function in R. One way to get help in R is to use the help function. Right, so let's go back to our script. Let's say we want to display the help file for a function called mean. To do this, we type help, then a pair of round brackets, and inside the brackets, the name of our function, which is mean in this example. You don't need to include the quotation symbols, but it's considered good practice to do so. Once again, we source the code into the console, and you can see that the help file is displayed in the bottom right-hand window. A shortcut for generating a help file is to use a single question mark followed by the name of the function. This does exactly the same thing as when we used the help function before. Both of these approaches are equivalent. Okay, let's move up to the upper right-hand window in RStudio. This window contains the Environment tab and the History tab. We're not going to cover the Connections tab in this video. The History tab lists all of the commands we've previously sourced into the console. If you wanted to rerun a line of code, you can click on the line of code in the history and then hit Enter to transfer the code to the console directly. Or if you hit Shift and Enter, you can transfer the code to the source editor instead. You can also remove lines of code from your history by clicking on this button, and you can also clear all of the history that you saved, or you can export all of your history to an external file. The other tab in this window is the Environment tab. This window lists all the objects you've created during the current session. So what do I mean by objects? Well, creating objects and then doing useful stuff to objects is one of the main ways that you and everyone else uses them. Okay, let's go through an example to clear some of that. To create an object, we first have to give our object a name. I'm going to create an object called numbers. You can really call that what you want with a few limitations. To assign a value to our object, we use what's called the assignment operator. Sometimes it's called the get operator. This is a combination of two symbols, which is a less than symbol and a hyphen, with no space between those symbols. To the right of the assignment operator, we provide a value to assign. In this example, I'm going to use a function called C, which is short for concatenate or combine. And I want to join the numbers 1, 2, 3, 4, and 5 together. The numbers inside the round bracket are called the arguments, which tells the C function how you want it to work. In this case, the arguments are just the numbers 1 to 5 separated by a comma. So let's go over that again. We're going to create an object called numbers, and we're going to assign it a value using the assignment operator. And that value is the numbers 1, 2, 3, 4, and 5 joined together using the concatenate function. We again source our code into the console. And now you can see in the Environment tab, we have a new object called numbers. It's a numeric type object. It has 5 entries. Its length is 5. And in this case, it shows you the 5 numbers. Another way of listing all the objects that we've created during the current session is to use a function called ls, short for list. This time, we're going to type directly into the console, so we don't really need to save this line of code. And here you can see that we have an object called numbers. To display the value of the object, we simply type the name of the object into the console, and the value is then displayed. In this case, it's the numbers 1, 2, 3, 4, and 5. To remove an object from our current session, we can either place a tick in the box next to the object name in the Environment tab, and then click on the broom icon, or we can use the RM function, short for remove, directly in the console. So if we type RM and then a pair of round brackets, num,